An underwater volcano off the Oregon coast, known as Axial, is showing signs of a possible eruption by 2025. Located 300 miles west of Cannon Beach, this volcano is a prime study site for scientists. Axial is an underwater volcano that has experienced eruptions in 1998, 2011, and 2015. Thanks to its regular activity and relative proximity to land, it was chosen as the site for the world's first underwater volcanic observatory, the New Millennium Observatory. This observatory allows the movements of the volcano to be monitored in real time. Scientists have observed that the surface of the Axial volcano is rising, a sign of moving magma that could herald an eruption. William Chadwick, a geologist at Oregon State University, reported this inflation during the American Geophysical Union annual meeting in December 2024. The volcano's surface has reached 95% of its level before the 2015 eruption. After a period of calm between 2015 and 2023, seismic activity resumed in the fall of 2023, with a notable increase in January 2024. The ground has risen at a rate of approximately 25 centimeters per year, accompanied by hundreds of small earthquakes. Since then, the inflation rate has stabilized. William Chadwick and Scott Nooner, a geophysicist at the University of North Carolina at Wilmington, predict an eruption before the end of 2025. Their prediction is based on observing magma movements and patterns of seismic activity. Axial, being well monitored and not representing a danger to populations, offers a unique opportunity to study the precursors of an eruption. Volcanologists hope these studies will lead to a better understanding of the warning signs of volcanic eruptions. Although long-term predictions remain difficult, Axial serves as an ideal case for developing forecast models. Valerio Acasella, a volcanologist at Roma Tre University, highlights the importance of such cases in improving our understanding of volcanoes. Research on Axial could contribute to significant advances in predicting volcanic eruptions around the world. By studying magma movements and surface changes, scientists hope to refine their models for more accurate, longer-term predictions. Volcanologists hope these studies will lead to a better understanding of the warning signs of volcanic eruptions. Although long-term predictions remain difficult, Axial serves as an ideal case for developing forecast models. Valerio Acasella, a volcanologist at Roma Tre University, highlights the importance of such cases in improving our understanding of volcanoes. Research on Axial could contribute to significant advances in predicting volcanic eruptions around the world. By studying magma movements and surface changes, scientists hope to refine their models for more accurate, longer-term predictions. Underwater volcanoes, big differences from terrestrial volcanoes. An underwater volcano is a mountain or hill that is formed by the accumulation of volcanic materials under the surface of the ocean. These volcanoes can reach considerable sizes and are often found along mid-ocean ridges, subduction zones, or hot spots. Unlike terrestrial volcanoes, underwater eruptions are less visible but can have significant impacts on marine ecosystems. The expelled materials can create new islands or modify the seabed. Underwater volcanoes play a crucial role in plate tectonics and the geochemical cycle of the oceans. They contribute to the formation of new seabeds and influence the chemistry of seawater by providing minerals and gases. The study of underwater volcanoes like Axial allows us to better understand underwater geological processes and their implications for the planet. These investigations are essential to predict eruptions and assess risks to marine ecosystems. How do scientists predict volcanic eruptions? The prediction of volcanic eruptions is based on the observation of various precursor signs, such as earthquakes, ground deformations, and gas emissions. These indicators make it possible to detect magma movements beneath the surface. Scientists use sophisticated monitoring instruments, such as seismometers, inclinometers, and gas sensors, to track volcanic activity. This data is analyzed to identify recurring patterns and assess the risk of eruption. However, long-term predictions remain complicated due to the complexity of volcanic systems. Volcanoes can change behavior unpredictably, making it difficult to anticipate eruptions. Studies on well-monitored volcanoes like Axial offer unique opportunities to improve forecasting models. By better understanding internal processes, scientists hope to develop more reliable methods for predicting eruptions and minimizing risks to populations.